dxdt equals to ax, and we have solved a lot of example problems, right? And last class we were doing a series of reactions we have done, and A is going to B, B is going to C. Have we done? Yeah, A is going to B, B is going to C, or we are supposed to do it. We are supposed to do it, right? So last class we have done the two unsteady state problem. So our main theme is dxdt equals to x. And x bar t equals to summation I equals to 1 to n alpha I0 e to the power lambda I t u I1. Right? And what actually happens? This solution technique is possible because we have got distinct eigenvalues. We have got distinct eigenvalues. For distinct eigenvalues, it is possible to have, as we said, to get orthogonal eigenvectors or the linear independent eigenvectors for symmetric and non-symmetric matrices respectively. And in that case, what actually happens, if we see that if lambdas are negative, and at t tending to infinity, x bar t goes to x bar c. Some steady state. Now the thing is that if all lambdas are negative, x bar steady state will be what? 0. But if one lambda is positive, at least one lambda is positive. Sorry, one lambda is 0, not positive. If lambda is positive, you cannot go to steady state. It will be runaway situation. If lambda is positive, you don't have to think about the steady state. You say it's a runaway situation, it cannot be steady state. With time it will blow up. In fact, some reaction going on and some heat transfer process going on. And if lambdas are positive, you can say that, okay, I cannot get steady state. I can get thermal runaway situation. But if lambdas, one lambda is 0, in that situation is very, very interesting. We can get the steady state, and which is the corresponding value of lambda equal to 0. Okay, so that will give, and that eigenvector will be the only solution space. That eigenvector is only the solution direction. So eigenvector corresponding to lambda equal to 0 is the only solution direction for the steady state problem. So that is the way one can look at. So for example, if I have got this is the axis and there are this one eigenvector and this another eigenvectors for 2 by 2 matrix. There are 2 eigenvectors and symmetric matrix eigenvectors orthogonal. These eigenvectors corresponding to lambda equal to 0. Initially, with time, solution is propagating in that direction, this direction, and resultant solution will be somewhere. So, and when time propagates, this direction solution propagation will be dying, and only this direction solution propagation will be there. At time infinity, solution will be propagating along that direction. That's the philosophical perspective of the steady state solution, and the solution space will be along the basis vector or the eigenvector corresponding to lambda equal to 0. That's what we have done the first 2 problems, right? So next problem I have given is that A going to B, B going to C, right? Next assignment problem. A is going to B and B going to C, which is 2 second inverse and 3 second inverse. So this says that is the first order. This says is the first order reaction. Okay, says here we restrict to reactor operation to be also come out and the reactions to be first order. The feed to the reactor is pure at concentration of 1 gram mole per cc. Determine the evolution of concentration of A, B and C when the CS are at the steady state. The initial concentrations of A, B, C are given. So that means we have the initial concentration, the initial condition C at T equal to 0, which we say C is 0 is 1 gram per mole per cc. CB T equal to 0. CB0 which is 0 and CCT equal to 0, CC0 equals to 0. and the residence time is 4 seconds inverse. So residence time is 4 seconds. So remember that the entire reaction is occurring in CS2. The entire reaction is occurring in CS2. But you know, start and reactor. So if we want to write dCAdT, what should I write? Pardon? That's all. Just CS2. You have done. You are doing chemical reactor theory, right? Is that correct? Will that not be residence time? See, so I'm telling what mistake you are doing. You are saying Ca0 minus Ca and minus K1Ca. The units you are not thinking about at all. You remember that K1Ca has one of the unit, but Ca minus C is a different unit. How can you subtract two different units? Divided by tau 1, residence time. So tau 1 by tau 1, Ca minus Ca0 minus K1Ca. Am I correct? Yes? Yes, this is K1, this is K2. Okay? dCAdT. Remember that we are doing CSTR, not a batch reactor. And there is difference between CS2 and batch reactor. We have seen, I'm sure you are seeing it now with this chemical reactor. Is it covered? Batch CSTR, batch reactor, things are covered, right? dCAdT equals to, again, 1 by tau 1 CB final minus CB plus K1Ca minus K2Cb, right? It is
CM.
Yeah. Ca minus C. Final concentration minus initial, something like that. This is the way the CSTR equations are done, right? Ca minus C. Okay. dCc. Because CSTR, if you look at, this is the standard and things will be like this, right? This is the typical CSTR thing. Batch reactor is actually you are loading it. You are loading it unless the reaction is over or your time, say you are saying after 5 years, what you want to see. Load it, take it out, take the sample out, put the titration and get the batch reactor concentration. CSTR is not the continuous start and reactor. It is different kind of result. dCAdT 1 by tau 1 CCH minus CC, then plus K2Cb, because it is only getting produced, it is not reacting at all. So it is only plus K2Cb. But for B, it is being destroyed, but is being produced also. So that's why we have plus K1Ca and minus K2Cb. These are all basic kinetics we have seen this. So I don't want to spend much time. So these three are my reactions, and which will lead to the system of equation. We are trying to do it here. dxdt equals to ax plus b. This system will lead to dxdt equals to ax plus b. Am I correct? Yes. It will lead to dxdt to ax plus b. So what is your, and at steady state, so this kind of system is so interesting. If you look at steady state, what actually happens? We are actually having ax equals to minus b. But for this case, at steady state, ax equals to 0. We are getting ax equals to 0. So, in that case, what actually happens? Even if you get non-trivial solution, you will not get unique solution here. Because ax equals to 0 belongs to null space. If a is determinant of a is non-zero, a should be trivial. So, in that case, solution on steady state requires the initial condition, and you have to do time marching. We have done last class. We have done the non-unsteady state solution. You put t into infinity, you got the steady state. You could not get from it because you won't get unique solution. Ax equals to 0. So, unique solution can be obtained if the right hand side is non-homogeneous. That means if this kind of system is there and a determinant of A is non-zero, and definitely in that case you have a 100% guarantee to have unique solution. If determinant of A is 0, you can get non-trivial solution which is non-unique if rank of A is equal to rank of A. There are so many things to remember. Okay? So here there is a chance to have a steady state solution if determinant of A is non-zero, we can get the unique solution even without solving the unsteady state problem. But it is always better to check whether you are getting steady state solution from the initial condition with time getting to infinity. So first we will solve this algebraic equation, get the steady values, and let's look at the unsteady problem. So for this, so not what I am actually asking that. So it is quite obvious that we expected, which is CA, CV, CC, and matrix A is, you should supply me the value of matrices. K1 is given, K2 is given, tau 1 is given. So I want the matrix. You calculate the component and get to the matrices. Minus 2.25. Did you calculate who is saying it? Minus 2.25? Okay. Can you show me the calculations? How we are doing it? Let's look at. Did you do the calculation? Okay. So if you do like this, is a problem, you are not showing the steps. Yeah. I can do that in the class. I will not show the steps. I don't think you like it. How much you are getting? Minus? No. What you got? Not CA, not CF minus CA. That's the usual thing. CF minus CA, CF minus CB, CF minus CC. Minus 125 minus 1 by 1000. That's what we will be giving different kind of answers. It's like a gambling test. How much you got? See, A matrix will be what? A11 will be how much? I want the expression. The first entry will be minus 1 by tau 1 minus K1. K1 is 2 second inverse and tau 1 is given 4 second inverse, right? So 1 by tau 1 is 0.25 and K1 is 2 second inverse. It is coming minus 2.25. I don't know why so much confusion. I don't know. Simple value, putting the value and get the answer. And that much is I am not getting. It's really surprised. Very interesting. I'm not getting the simple manipulation here. At least for the GATE exam you should do it. GATE exam, this kind of questions should be there. Because all of you are appearing from GATE exam. Because these are stop gap. I always feel that your main job will come from GATE exam. So second is 0, 0. Then next is 2 then. What is that? Then next is next minus 0.25. Minus 0.25. Okay. So remember that to get the solution. So Ax equals to Bt. How to get the solution? Unless we should get in terms of eigenvalues and eigenvectors. That's what our agenda is. So we write the solution x bar, this summation, x bar is alpha I mu I naught. And B vector, we can write solution beta I mu I vector. So B is also a vector. Any vector can be expressed in a combination of basis vectors. My basis vectors are the eigenvectors. Okay? And so then how to get the solution? In terms of, so we have to get alpha and beta. Once you get alpha and beta, you got the solution. So, what is the solution? What's the solution? If this is given, how to get x bar? How to get alpha is unknown? How to get it from here? In terms of eigenvectors. Because this I am not intending to solve directly, because anyway need to find eigenvectors to analyze the system with time. So when you have eigenvectors ready, we can get the solution. Why to solve again? Just without solving. If these are given, how to get the solution? That's what I am asking. This is already covered in the first quiz. Whether this what I am asking is the first quiz only. This is not the second quiz. The first quiz covered it. Yes, of course, non-symmetric matrix. No, but how do I start it? So Sigma, remember anything? So it is A. See, that's what I want, but I am not getting this kind of answer. You should tell the steps. Alpha I u I bar equals to summation minus summation I equals to 1 to n beta I t should be because the function of p, or doesn't matter because we are talking about steady state, okay, and which is u I bar. So then next step will be because we have to find out alpha. Next step will be, this is the thing, I am really getting frustrated with, yes. Pardon? What is that? I am not able to hear about, I am not able to understand your English. What? Yeah, if you talk like this, you won't get the job. Okay. I am not able to understand your English. Maybe your English is different from my English. Yes. Yes, please sit down, please.
Summation I is equal to 1 to n on the left hand side.
Yeah. Alpha A U I, right? Summation I equals to 1 to n alpha I A U I equals to minus summation I equals to 1 to n beta I U I. And this is summation I equals to 1 to n alpha I lambda I U I because the eigenvectors minus I equals to 1 to n beta I U I. So, and if you look at these are the distinct eigenvalues and this U I will form the basis. Okay? And thing is that since the matrix is non-symmetric, these are not orthogonal. UIs are not orthogonal. So there is a criteria called bi-orthogonality. We have done for the non-symmetric matrix with the complex conjugate, and this is also called as bi-orthogonality criteria. If you impose bi-orthogonality criteria, what will be the value of alpha I1? That's a final. What is alpha I equals to? Let me see who can give me the answer. Alpha I will be inner product. So we can, instead of this one, we can also put directly like this, no problem. I just wrote beta, but we can directly put b. So inner product minus b bar b divided by lambda ui vi. And you just see that beta doesn't have any role to play directly to b1. b1 vector is 1. Okay, I wrote beta ui as a generalization. You need it. When you put dx equals to ax plus bt, you need in terms of beta, but not now. So this is the expression for alpha, right? So this is the expression for alpha. So once alpha is unknown, my solution is alpha ui bar. Okay. So what are the eigenvectors? Eigenvalues first of all. What are the eigenvalues? Eigenvalues. What is that? What is that? Yeah, minus 2.25. Only one eigenvalue? Yeah. So if you look at the diagonals, actually the eigenvalues, and in fact if you calculate, you get the same answer. So if you calculate, is lambda 1 is minus 2.25, lambda 2 is minus 3.25, and lambda 3 is minus 1.25. Okay? And corresponding eigenvectors. One is the corresponding eigenvectors. You can have eigenvectors. What are the corresponding eigenvectors? What are the corresponding eigenvectors? Corresponding eigenvectors. 1, 2 minus 3 is first eigenvector. 1, 2 minus 3. U2 0, 1 minus 1, and U3 is 0, 0, 1. So now we can actually have a transpose matrix, and A transpose will have the same eigenvalues but different eigenvectors. So now it is possible to have the different eigenvectors V1, V2, and V3. So what are the eigenvectors for the transpose matrix? Remember that inner product of U1, V1 is non-zero, whereas inner product U1, V2 equal to 0, U1, V3 has to be 0. Right? So what will be V1? What will be V1 then? A transpose matrix, very simple. I have done these kind of things many times. What will be V1? What will be V1 then? What will be V1? A transpose system. System is A transpose. System is A transpose. At this one eigenvector you supply, other two eigenvectors I can give you. I not paint. At least one eigenvector you can give me. At least one eigenvector please give me. You don't want to do anything. Sir, I am not a fool. Okay? I am sorry. But I don't know what you want in your life. If you say you are doing, then maybe I am blind. You disprove it and will happen. Yes, I am really surprised it takes so much of time. 100. Next is minus 210, and third one is 111. So, and now I am asking another question now. What is your B vector? I have not asked so far. Now it is the right time to have the B vector. What is B vector? So if you write Ax equals to B, then it should be minus 1 foot. So I am putting plus B. Then it is minus 1 foot, 0. Okay? So B vector is minus, so if I write Ax equals to Bt, in that case B is minus 1 foot, 0. Okay? In that case, what are my solutions? So now, this will give the steady state solution. When I get X equals to this summation alpha I uy x vector, this is my steady state. SS, steady state solution. The x bar SS is summation alpha I uy bar. And alphas, alpha 1, alpha 2, alpha 3 are. Now you get the answer, alpha 1, alpha 2, alpha 3. What are my values? What are my values? What are the values of alpha 1, alpha 2, alpha 3? Alpha 1 is minus. Are you sure? I got 1 by 9 minus 2 by 30 and alpha 3 equals to 1. Okay. So if you see the steady state values, so C, if you want to write CASS, CBSS and CCSS, steady state values, which is Uy of summation of alpha Uy 1 by 9, U1 is 1 to minus 3 plus. It should be minus 2 by 30, which is 0, 1 minus 1, and it is 1 to 0, 0, 1, and which will give 1 by 9, final answer, 8 by 117, and 32 by 39. So these are my steady state solution. So your answer should be benchmark because the steady state values cannot be negative. If you say concentration is negative, I am done with the class. It has to be positive. So alpha and alpha 2 values are correct, what we got, and that's what the steady state values. Now what I am going to demonstrate, this problem we have solved directly a steady state problem. Now we'll solve the unsteady state problem and show that at time tending to infinity it will reach the steady state values. Right? And in that way we'll be demonstrating to solve dx equals to ax plus bt. We have not done it, and we have done the solution for dx equals to ax, and dx equals to ax plus bt has extra challenge because of the complexities involved in the integrating factor we have done in 2 classes back. So let's look at how to solve the same problem with a time dependency. So far we understood this problem we have solved for the steady state problem. We got the steady values, there is no time dependency, and we will now going to address dx dt equals to ax plus bt. Okay? dx equals to ax plus bt. And the solution already we have got earlier the solution. You remember the solution? dx equals to x plus bt. What is the solution? We have done it. Solution is x plus t is summation I equals to 1 to n alpha I t u I bar. And our matrix is non-symmetric. Okay? So, and anyway, alpha I t we got in terms of alpha I0 e to the power lambda I t plus e to the power lambda I t in integral 0 to t e to the power minus lambda I tau beta I tau d tau. Okay? By beta I, you know that b is nothing but summation of beta I ui bar, and beta I can be obtained using the orthogonality criteria or the bi-orthogonality criteria for the complex conjugate system. If I have not mentioned bi-orthogonality criteria, that criteria, please go back to class note and write down that criteria is termed as bi-orthogonality criteria. Which criteria? When the matrix is non-symmetric, the or eigenvectors are not orthogonal, but eigenvectors are orthogonal to the corresponding eigenvectors of the complex conjugate system. So in that case, inner product of ui bj bar is equal to delta ij, and I equals to j equals to 1. If I equals to j, that criteria is also known as bi-orthogonality criteria. Please go back and write. Did you write down? Of course, no, we are not writing down. And you will say I am writing down. You are a great man. You are so smart. I like your attitude. I wish I would have been like you. It is your problem, you know. If you want to fail in the class, you can tell me I can do that. But if you attend the class and fail the class, it's really pathetic, because I am always in your side to pass the candidates. It is against my nature to fail a candidate, unless you are really working hard to do that, and I think you are going to that direction. I really appreciate it. Okay. Okay. So these are the things we have done already, and we have the beta it, and beta it is how much? So remember that determination of alpha it equals beta it. Okay, so beta it will be inner product. Beta it will be inner product. Inner product. B is there less, because B bar T is nothing but summation I equals to 1 when beta it ui bar. Okay, so beta it equals to inner product B, yes, bj bar divided by, it should be bi bar, not bj, because I is there, so it is ui bi bar. Okay. So now you have a Herculean task here, and what we can do that immediately we can calculate beta 1, beta 2, beta 3 from your previous calculation. The previous calculation we found d1 bar, d2 bar and d3 bar. We have the b vector. Can you please tell me the answers d1, b2 and d3? Can you please tell me the answers? Beta 1, beta 2 and beta 3. How much are they? Please tell me the answer. Beta 1, beta 2 and beta 3. That much I think you can calculate. It's pretty straightforward. You have the d1 bar, d2 bar, d3 bar. Once you have d1 bar, d2 bar, d3 bar, you can calculate beta 1, beta 2 and beta 3. Minus 1 by 4, yes. Next. Beta 2? Huh? Beta 2 is 0, so you are actually doing real shortcut business. Shortcut doesn't work. Yes, madam, anything you got? No, not minus. 1 by 2. But we are doing that thing, fine. Beta 3. Beta 3. Beta 3. This is minus. 1 is how much? Minus 1 by 4. So beta 1, beta 2, beta 3 have been obtained. Now we are solving dx equals to x plus bt. Our solution is given by this. Ui bar is known, only alpha ti bar is unknown. If we get alpha 1, alpha 2, alpha 3 in terms of time, we get the solution. Our approach is you put time in the tending to infinity, and we have to see whether we are getting these solutions. If not, there is some problem. Okay? And remember that in this case, all lambdas are negative. There is no lambda 0. Okay? So what actually happens? This guy will go to 0 at t tending to infinity. Okay? But there will be some interesting episode in the beta I term. So we will see that how alpha 1 actually behave. Okay? How alpha 1 t, alpha 2 t, alpha 3 t. Because here, if you remember that lambdas all are negative, and that actually gives an interesting episode. If all lambdas are negative, your system must have steady state solution. If any lambdas are positive, the solution cannot have any steady state map. So the first way. So when you give a problem which has steady state solution, always the first thing to see whether all lambdas are negative. If the system is homogeneous, at least one lambda has to be 0 to get non-trivial steady state solution. If all lambdas are negative, for homogeneous system, we will get trivial steady state solution. Let's look at alpha it. So this is the only part remaining. This is the only part remaining. Once you know alpha it, you get the solution because you know UI cos. These are diagonal vectors. So let's look at how to calculate alpha it. Okay? So alpha it has two parts. We have alpha 1 0, alpha 2 0, and alpha 3 0. What are they? How to calculate alpha 1 0? So from here you can see x bar 0 is nothing but alpha I 0 ui. So alpha 0 is nothing but inner product of x bar vi bar by inner product ui bar vi. Okay. So x bar 0 is obtained, which is the initial condition, which is given as CA is non-zero, which is 1 0 0. So x bar 0 is also given. X bar 0 is also given, which is 1 0 0. X bar 0 is 1 0 0. So in that case, alpha 1 0 is how much? Alpha 1 0 is how much? 1. Alpha 2 0 is? 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 Minus 2 and alpha 3? 1. Okay. Yes. And B vector is already given, which is minus 1 by 4 0 0. Okay. B vector is already given, minus 1 4 0 0. And beta 1, beta 2, beta 3 are given, minus 1 by 4 after minus 1 by 4. So what is alpha 1 t? Everything is given. Now I have won the first answer, alpha 1 t, which is alpha 1 0, which is 1. E to the power lambda 1 is minus 2.25, I can say 9 by 4. Am I correct? Minus 90 by 4. First term is over. Second term. Second term. E to the power 9 by 4 t integral 0 to t e to the power plus is which is minus 9 is plus 9. 9 by 4 tau. Beta 1 is minus 1 by 4 d tau. Do the integral. So integral is, if you look at e to the power minus 90 by 4 integral 0 to t e to the power 9 tau by 4. Beta 1 is how much? Minus 1 by 4 d tau. Now we can see this, if you do integral, you will see how things are actually coming, because tau is a dummy value. If you do the integral, this integral is very straightforward. Minus 1 by 4 will be coming here. You do the integration, and what you will get? You will get in terms of t only. What is alpha 1? E to the power minus 90 by 4. And then what term you are getting from here? We will be having two terms. Remember that. E to the power 0 will be having 1. If you are doing definite integral, unless you do that, you won't appreciate what I have done. Unless you do by hand. Unless you do by hand, which is nothing but 10 plus 2 calculus. Unless you do by hand, you will not appreciate. Unless you do by hand, you will not appreciate. Please do by hand to appreciate it. Please do by hand. I want your calculation. I want your calculation. What's the calculation says? It's like a definite integral. It will be plus 1 by 9. In bracket something will be there. What is that? 1 has to be there. Minus e to the power minus 90 by 4. Am I correct? Yes or no? Yes? Yes? What is alpha 2p? This I will not, you have to do it. Because first one I have actually given the answer. This answer I will not give. Unless you do that. Alpha 2 remember as minus 2. So first term is very straightforward. Second eigenvalue is minus 3.225, which is nothing but 13 by 4. Right? 3.25 is nothing but 13 by 4. So it is minus 2e minus 13t by 4. Next term I will not give. Next term I will not give. Next term I will not give. Yes, simple definite integral. It's simple definite integral. I'm really surprised to see that you cannot do definite integral, which has been done in 10th class. Simple definite integral. It's simple definite integral. I'm really surprised that you are not giving me the answer, which is supposed to be done in 10th class. Plus, it should be minus, because I want to answer in this kind of fashion, 1 minus something. So it is minus. What is that term? No, the constant term is how much? 8 by? No, it is not 8 by 13. How much? Who said 2 by 13? 2 by 13, only one answer, 2 by 13. Any other 2 by 13? 2 by 13? Yes, 2 by 13. I want to reconfirm. One answer I will not be happy with. Next in the bracket, 1 minus e to the power minus 13t by 4. Last eigenvalue is t by 4, is 1 by 4, 0.25. So alpha 3t is, which is e to the power minus t by 4 plus 1 into 1 minus t by 4. Now with this, you have come to the last step of the problem. With this, you have come to the last step of the problem. So you have got all alphas, alpha 1, alpha 2, alpha 3. And in that case, your solution, x bar, which is CA, CB and CC, which is nothing but I equals to 1 to n, alpha I t u I bar. Alpha I t u I bar. Okay? X bar is nothing but summation of phi t u I bar. Okay. Summation of phi t u I bar. And alpha I t is actually obtained. So, what is, so from here, what will you get? CAT, CBT, and CCT. Everything is given to you. So, it is nothing but alpha 1t u1 bar, alpha 2t, alpha 1t u1 bar, alpha 2t u2 bar plus alpha 3t u3. u1 bar, u2 bar, u3 bar known, right? Alphas are known, alpha 1, alpha 2, alpha 3. They are all known, 1 minus, it is as a function of time. So if you do the manipulation, you get the time dependent function. So C8 as a function of time, CB as a function of time, and CC as a function of time. So you get time dependent function. You get time dependent function. You get time dependent function. So what is that? CAT. Everything is given to you. You will have the eigenvalues, eigenvectors. Everything is given to you. Only all you have to do is to multiply this guy by eigenvector. This you have to multiply by eigenvector. So there will be two components. One is the contribution from here. Another thing is contribution from here. And the two terms you will get for each of the things. Involving this kind of brackets. So always this bracket will be there. I am giving you so much of hints, and this bracket is 1 minus e to the power minus 9t by 4, 1 minus e to the power minus 13t by 4, and some other terms will be there, some other terms will be there. First CAT is very straightforward. What is that? E to the power minus 9t by 4, when? Yes. Next CBT. 2 or 2 minus 90 by 4 minus 2e 13t by 4 plus 2 by 9 e to the power minus 9t by 4, and this is another term will be there. Plus 2 by 3, unless you are having problem with the plus or minus, whatever, yeah, whatever I say, if I say plus, Vasudha will say minus. I don't know, some problem is there. Minus 2 by 13, 1 minus e to the power minus 13t by 4. CCT equals to, okay, is a big term. So 3 minus 3e 9t by 4. Next. Minus or plus 2e minus 13t by 4. Next term. E to the power minus t by 4. Next term. Minus 3 by 9. 1. 9t by 4. Plus 2 by 13. 1 minus e 13t by 4. Plus 1 minus e to the power minus t by 4. Now, if I put t tending to infinity, what I am getting? If I put t tending to infinity, this term will go, and what will you get? I think here slight mistake is that it should be 1 by 9. 1 by 9, right? So CAS, so from here, we get CASS, which is 1 by 9, which is roughly around 1 by 9 is roughly around. Okay, fine. So I won't, because this is actually we also got in the, now you see the solution. AX equals to minus B, the solution you got, and there also you got 1 by 9, right? So that is the benchmark. So you got the statistic solution directly. Now you are getting a time approach, acting to infinity. You got the same solution. Similarly, CBSS is how much? This term is going, this term is also going. Yes, and this is also gone, this is also gone. So these terms will remain. 2 by 9 minus 2 by 13. How much will be getting? 2 by 9 by minus 2 by 13. How much will be getting? 8 by 117. Next is CCCSS, which is 32 by 13. So now if we look at these numbers and you got AX equals to B solution. So this is a complete problem. So what we have solved, one of the most generalized kind of problem is you put AX plus BT with this kind of thing, and this will be quite useful when you solve many such problems. But this is one of the real chemical engineering problems we have solved, which is nothing but A going to B going to C. This is a very simple reaction in level speed. It's a very simple simple reaction, but you see how much it is the complications. In simple reaction, I have taken A, B, A is going to B, going to C. In a case here, I wanted to see the time dynamics, time dependent profile, not only that, the steady state problem, and that leads this kind of interesting episode. So, next problem in the assignment. I read the problem and then I can read. Determine the heights of H1 is in the 2 can network shown in the figure. The equations are given by, it is given, right H1 and this T2T, and now this problem is very, very straightforward, to me, because we have solved very difficult problem. And what I expect tomorrow, the time dependent part, I want the answer from you guys. And next, I think I'll be going to the different topics, and thanks for your time.